Hi, this is Daniel from Teradata. As you know, a lot of business models nowadays rely on subscriptions, and it is very important for organizations to be able to model churn, to identify what customers are likely to withdraw from their services and what are the drivers behind those withdrawals to adjust their business models appropriately. Teradata offers a wide variety of in-database analytics functions that make modeling churn very easy and convenient. In this demo, we are going through one use case where a telco company is modeling churn using these tools. If your company relies on subscriptions, you want to watch this video. Follow me to it. To follow this demo, go to teradata.com/experience, create your account in ClearScape Analytics Experience, then go to ClearScape Analytics Experience, sign in to the website, start an environment, and remember what is the password that you are using for the environment. Click on Run Demos. You are going to see a Jupyter Lab environment appearing in your browser, and then go to Use Cases and look for Telco Customer Churn. You are going to see this notebook, which we are going to start describing right now. We are going to model churn. That is, we are going to try to predict what customers are most likely to stop their contract with our telco company, or the same, stopping their subscription. You might already see that this type of analysis is relevant for several industries, since a lot of business models are based on subscriptions nowadays. We are going to start by downloading the libraries that we need and installing those in our Jupyter Notebook. We are going to connect to our Vantage environment. Here you're going to need your password. We are going to download the data. Then let's take a look at the columns. As you can see in the data, we have several columns that are related to either characteristics of the customers or their contract with our company. Characteristics of the customers regarding to whether it is a male or female customer, whether the customer is a senior citizen, whether it has a partner or dependents, that means a spouse or children, and the months of tenure with our company. Then we have certain contract related data as regarding to whether the customer has a phone service, whether it has multiple lines, and so on and so forth. To get a glimpse of how the data looks like, we can take a shape of the data. So we have more than 7,000 records in this demo data set, and we have 21 columns that are regarding this contract or customer's characteristics that we already discussed. We are going to perform a column summary to see what type of data do we have. Remember that it's very common that we have columns that are numerical, and we also have columns that are categorical. Some columns have a specific numerical value, and some columns are categories in which we classified the customers. For example, gender, that would be categorical. We have a lot of those in this data set, and we can take a look at them in this summary here. We can see the column types, and we can have an idea on which ones are varchars and which ones are integers or numbers. Typically, the ones that are integers or numbers of any type, those are quantitative, and the ones that are varchars, those are usually categorical data. There's a section here in this notebook related to exploratory data analysis. So basically what is going on here is that we run several statements trying to partition the data between the categorical variables that we have and the churn, and check, for example, what is the breakdown of churn customers as regarding to that category. We can do a couple of those just for sampling. So we have our categorical data of gender split almost perfectly in half. And we have the categorical data of churn. It's a very high percentage of churn regarding this data set. We also can make an analysis where we can see the churn by gender. And we can see here the number of churn customers broke down between male and female. And we can see also kind of like a 50-50 divide. And we, of course, can graph the above data, and we will have this little graph here. Gender is not usually a good predictor of churn. This 50-50 divide is actually quite natural in this type of data set. Now, let's try to get data broke down by the contract type. It's also going to give us a little bit of an obvious result, and you are going to see it right away when we run the data. And we can see that the churn customers, most of them have a month-to-month contract. Of course, people is more likely to churn if there is no cost for them to churn. So month-to-month contracts, of course, are going to be the bulk of the churn contracts. This is actually not that meaningful. And we can see that these variables, some of them are very obviously unrelated to churn, such as the gender, and some of them might be very obviously related to churn, just as the contract type. If people doesn't have any cost for them to churn, people that don't have set cost are more likely to churn. And what we are going to do next is to build a model that takes into account all of those variables, the ones that we think are not really that related to churn, such as gender, the ones that we know that are very likely related to churn, such as the contract type, and others, such as whether they have an internet service or what type of payment method they're using, that we actually might not see any relationship. And we want to model all of those variables to try to see how they influence churn. And for doing that, we are going to do a multivariate regression on top of all of those independent variables to try to predict our dependent variable, which is the customer churning or not. Let's go to the next section for that. But before we build our regression model, we need to do a little bit of housekeeping. And let's take a look to our categorical variables. And we're going to take a look at them with this command here that is showing us a categorical summary of those columns that we have here. As you can see, we're using the categorical summary function from Teradata ML. So this categorical summary is generated purely in database and is giving us a very nice breakdown of the values that we have in each of the categories in these columns. And we see something interesting here. We have device protection. It has no internet service, yes and no. And this might be meaningful for a reason that we are going to review right now. I think there are like 23 or so records. And this is what I want you to see. So remember that we have this yes, no, but no internet service in device protection. So that means that the device protection is only active when the customer has internet service with our company. And to take note of that in the data set is telling us no internet service, but it's actually a no. And we can see that the same happens with online backup, online security, streaming movies, and streaming TV. So these are actually no's, but since they are sort of a special no, there is another value there in that category for those specific cases. And this is really not good for our regression because we want to have these categories between yes and no. There is another categorical value, which is whether the customer has an internet service, which is DSL, fiber optic, or no, that will model whether the customer has this internet service or not. We don't need that classification in the values of the other categorical columns that might be related with this internet service. And we have the same happening with the phone service. So we need to normalize this. We want this to be no's. So that's the next step. We're going to get some transformation in the data, adding extra columns that we are transforming to normalize those values. So what we're doing here is taking the values of these columns that we have before, and if they say no phone service, we are putting that one to no, and the same with the ones that are talking about the internet service. And here you cannot see it in the main columns yet because we have not transformed those, but we have added new columns here that are already transformed with a no in the case we have this type of categories here. Now that we have those extra columns, we're going to drop those originally present in the data, and we're going to rename the other columns with the name of those that we are dropping. What this is going to end up doing is that we're going to have a clean data set that will have the values of the categories as we want them to be. Now that we have our data properly clean in that sense, we can display the resulting data frame, which again is a Teradata ML data frame, a virtual data frame that has exactly the same behavior as a pandas data frame, but that exists in database. All the compute is performed by Teradata Vantage. And we have the results here, and you can see that right now we have only yes or no's. We don't have these no phone service or no internet service values. And now that we have those transformed to just yes or no, we can proceed to the other step that we need to perform first before building our regression model. And that is that we are going to encode these values, the ones that are yes and the ones that are no, to a 0 or a 1. And to do that, we are going to utilize Teradata's in database analytics functions. So we are going to get all of these categories that have values of yes or no. We are going to encode them in zeros or 1 with this specific command. Here you can check the documentation, but basically we are just sending the target columns and how many categories we want, which is just a 0 or a 1 because it's one hot encoding. For Teradata encoding and transform functions, they usually come in pairs. So you will have a function that fits the data to a specific statistical characteristics, and then you have a transform function that actually performs the encoding. So first we produce the fit function, and this one is for the ones that are zeros or 1. But in our data, as you remember, in the case of the internet service or the contracts or the paperless billing or payment methods, we don't have yes or no values. We have actual categories. So these categories are not only two, they are categories such as internet service that we have the DSL, or we have cable, or we have no service. For these cases, we are going to apply another encoding to transform the values to numbers. And this is going to be ordinal encoding. So we assume that there is an order between those categories. So for example, the no service or no internet service is going to be 0, for example, and then the DSL is going to be 1, and the cable is going to be 2, and so on and so forth. For this, the way to do it is that we are going to define a default value. That's when there is no category there or null, which is not the case for us. But if that's the case, we are going to have a -1. That means all our categories will start at 0, and we are going to model them like that. We are going to do the fitting, and that will provide us the basis for performing the transformations later on. The last transformation we need to perform is regarding the quantitative data. This data, the monthly charges and the total charges, might be in very different scales. You have the total charges for a customer that might be all over the customer lifetime value, and you have monthly charges. So we want to keep them within a range that will allow our regression to be more precise. And for this, we are going to fit the data to a range between 0 and 1, and that's the way the data is going to be transformed. This is the last transformation. After we have done that, in summary, we would have transformed our yes or no categories into zeros or ones. We would have transformed the categories that are no yes or no to numbers, and we would have normalized the quantitative data to a similar scale. This will allow us to build our model. But as mentioned, the transformation has not happened yet. We have just built the fitting models, but we need the transformer. And Teradata offers very convenient functionality to perform those transformations in one go, which is the column transformer. And now we are going to produce a data frame that contains all the transformed data. With the transformation performed, we can take a look to our new data set. As we can see here, the monthly charges and the total charges are normalized. We have our data that was yes or no's transformed into zeros or ones, and we have our ordinal values, such as we had in the contract type, also transformed to an ordinal series that starts at 0 and ends at 2. With this data, we can model a regression. But first, we need to split it. We want to train our model in a lot of this data, but we want to keep for ourselves certain data set that our model would not see in its training phase, and that we are going to use afterwards to see how well the model is performing when it comes to classify data that it has not seen before. So first, we are going to take a look at our data, what shape it has, and we have this amount of rows and columns. We are going to create that data set in the database, and now we can perform the split. And of course, as expected, Teradata has a convenient in database analytics function to perform this split for you. We are going to take 75% of the data to be our training set, and we are going to reserve 25% to be our testing data set. Also, this happens at random, so we need to provide a zip, and this concludes our pre-processing of our data. Let's go to build our model. We are going to check that we have our data frame that we're going to use to train our model, which we created before. And now we are going to send that training data set to our model that we are going to train. This is going to be a classification that will be able to take the data and predict the likelihood of a customer churning or not. We are going to use Teradata's in-database analytics functions for this. The model was created. We can check the result, and this is the values that is going to assign for each of the independent variables. Now we're going to predict using our testing data set which customers are churn or not. And we have the results. We have for the first 3 customers here, we have the prediction of our model was that the customer didn't churn, and the facts were that the customer didn't churn. The fourth one here is the opposite case. We have the customer churning in our prediction, and that's the fact. So at least in this data that we can see here, we don't have false positives predicted that the customer will churn when in fact it was not the case, and we don't have false negatives, meaning that we said a customer would not churn and it actually churned. We have a much better way to evaluate how well our model did instead of eyeballing the data. And for that, you know the answer. Teradata has a very nice in-database analytic function that is called the classification evaluator, and we are going to call that one, and we are going to get a set of measurements on how well the model performed. On top of this, we can build a graph that will allow us to know how well the model performed. And this graph is called receiver operating characteristic curve. The higher the value that we have there, the better the model performs. And we have here that the area is 75%, so is actually not bad in the predictions, and here is the curve. It's performing reasonably well. Of course, it's not yet perfect, but we can feed more data and we might get better results. Or we can try another method. And this is for you to try. Go to ClearScape Analytics Experience and try the other method, which is extreme gradient boosting, and you might be able to see if that one performs better than our regression model. If you happen to have any questions about this specific demo notebook, don't hesitate to let us know in the comments of the video or in our community website, support.teradata.com/community. See you there, and I hope this has been useful to you.